All right, let's talk a little bit about interest rates, present value, and future value. So we're going to denote an asset's present value with PV. And let's say that some asset earns an interest rate I every period. And after n periods, the asset's future value is, well, we use this equation here, right? So the future value equals the present value times 1 plus the interest rate to the nth power, right? And this is what happens when interest is compounding, right? Basically, you have interest that is going to be added based on the value of the asset, and then also subsequently, it's going to, you're going to be earning interest on the interest as well if you have this asset, right? And so that's what this captures here, since it's it's compounded n times by multiplying by 1 plus I to the nth power. All right, let's see a little example to illustrate this. So suppose you have a savings account with a present value of $100, right? So a savings account with $100 in it. And let's say that the interest rate on the savings account is 7% annually, right? So every year it makes 7%. Now, if you do not make any deposits or withdrawals from this account, then after n equals 2 years, the account will have a future value of, well, plugging all these numbers into our formula, right? So the future value equals the present value times 1 plus the interest rate to the nth power. So 100 times 1.07 to the 2, right? 2 years, interest rate is 7%, present value of $100. All right, well, doing this 1.07 squared, we find that that's 1.1449, right? And doing the multiplication, we find that that's going to yield an account where the value is $114.49. Now, taking a step back and thinking about this for a moment, notice, okay, well, we probably knew it was somewhere around $114, right? Because they're earning 7% interest, start with $100. So first year, it's going to earn $7, right? And then second year, okay, it's going to earn another $7, but then you also have to count the interest on the interest, right? And this is where the compounding comes from. And so this extra 49 cents is because, well, you're earning 7% interest on that $7 that 7% interest in the second year on the $7 you earned in the first year as well. And that's where this extra 49 cents comes in. So you can see the effect of the compounding interest here, and is that, well, you end up with an extra 49 cents after 2 years. And of course, this just adds up and gets even bigger and bigger. The compounding has a larger effect the more years you go, right? Okay, now this brings us to the next topic I want to touch on that relates to this, and talking about the time value of money and time preference. Now, ask yourself this question: would you rather have $5,000 now or in 10 years? Almost everybody would take the money now, right? And this preference for money earlier rather than later, this is called the time value of money. And of course, people have different time values of money, right? And how much more you value earlier money, right? Money earlier rather than later, depends on your time preference, right? It depends basically on how impatient you are to have money and to be able to use it. And this can be measured by the rate of interest that's necessary to make you indifferent between amounts of money at different times, right? So let's look at a little example to illustrate this, right? So imagine that you're somebody who's indifferent between $1,000 now and $1,150 a year from now, right? So you are just as happy taking $1,000 now or waiting a year and instead getting $1,150, right? Well, this means that to you, right, personally, the present value of $1,150 in 1 year, right, getting that $1,150 in 1 year, the present value of that is $1,000, right? Or equivalently, the future value in 1 year of $1,000 now is $1,150. So future you would put a value of $1,150 on getting $1,000 now, right? A year previous relative to the future you, right? So these kinds of things are, they can kind of flip back and forth, right? Once you have one statement about present value, then you can figure out future value, right? Now let's go ahead and plug these in and figure out what the interest rate is that describes your time preference, right? So plugging these values in, notice we have n equals 1 into our equation, right? It's just 1 year, 1 period. So plugging that into our equation, again, here it is, future value equals present value times 1 plus the interest rate to the nth power. Well, we find, okay, the future value is $1,150. The present value is $1,000. And we're solving for I, so we have 1 plus I, and again, it's just one period, so n is 1, so it just kind of disappeared, right? Because anything to the first power is just itself, so we can essentially get rid of the n equals 1. Now, solving for I here, it's not hard to see that I equals 0.15, or 15%, right? So what that means is that the annual interest rate that describes your time preference is 15%. One might also say that you discount the future at a rate of 15% per year, right? So yeah, that describes your time preference, 15% interest. All right, now, like I was saying before, you can kind of go back and forth between future value and present value. If you know one and you know the interest rate and you know the number of periods, then you can figure out the other. So we can calculate present value from future value since our equation implies, if you divide by 1 plus I to the nth power, if you divide this equation by that, by 1 plus I to the nth power, then you can see that you get present value equals future value divided by 1 plus I to the nth power. So let's use this in a little example, right, to kind of illustrate present value calculation. So suppose your rate of time preference is 8%, right? So you discount the future at a rate of 8% per year, and the government is selling bonds for $490, and they promise to pay back $540 in 1 year with zero risk of default, right? So anybody who buys one of those bonds for $490 now will get $540 in the future for sure. Now, the question is, would you buy the bond? Right? Would you buy the bond? Would it be rational for you to buy the bond given your time preference and these other, bond value parameters? Well, one way to answer this question is to calculate the present value of that $540 in 1 year and compare it to the $490 it takes to buy the bond, right? So plugging future value of $540 and an interest rate I equals 0.08, and of course n equals 1, since again it's just 1 year. Plugging that into our expression yields, well, we get the present value is $540 divided by 1 plus the interest rate, so 1.08. And this happens to this equals $500. So the present value of the bond is $500, and that's greater than the cost to buy the bond, right? $490. So to you, the bond is worth $500 presently, right? And it only costs $490. So actually, you would think that that's a pretty good deal, right? Given all those parameters, given your time preference and the values of the bond, you think that this is probably a pretty good deal. So according to all this analysis, you would actually buy the bond, right? You would think it would be a pretty good investment and it would be worthwhile to do. All right, so that's it for this video. Thank you so much for watching.